Good afternoon. Assalamualaikum. Today we will proceed with, still continue with chapter 3C for the water gas shape equilibrium reaction. Okay, we had done last class on the example. So today we will proceed with the exercise. This is from final exam question 2018. Okay, how to know whether it is water gas shape reaction or not? The question will inform you. Okay, there will be a statement if this process is involved with water gas shape reaction. Okay, so this question, it gives you fuel of gasoline with the given chemical formula, burn with air at an equivalence ratio of 1.1. Okay, this is the equivalence ratio. So pressure 1 atm, temperature 250. It asks you to compute the equilibrium composition of the combustion product, assuming no dissociation except for water gas shape reaction. Okay, so water gas shape equilibrium. So from that statement, it shows you that we have this is incomplete combustion. Okay, because water gas shape reaction occurs in incomplete combustion only. Okay, where the CO react with H2O will form CO2 and H2. Now, first thing first, identify the question asks you to compute the composition. So that means you need to know what are in your flow gases. Composition here means the mole fraction of your gases. Okay, so first thing first, always generate the combustion equation first. Your fuel is gasoline. They react with A actual, equals to your CO2 is unknown, H2O plus what else? What is in your flow gases? CO plus H2 plus N. Okay, so I use B, C, D, and E for the unknowns. Now, how to find the A? You are given the equivalence ratio over here. How to find the A? A stoic we can get from the molecular formula. But how about A actual? Okay, A actual. How to find the A actual? There is no percent of air given. You only have the equivalence ratio. The one is A stoic. Y/4 is A stoic. Divide with the equivalence ratio to find the A actual. Okay. Remember, this is one of the equation. So from here, what you get for A actual? Sorry? 10.56. The rest get the same? Okay, now we need to find out for B first. Since it involves water gas shift reaction, so you need to find the B before you can find the C, D, E. So for the B, you will need to use this equation. This long equation, which involves the Kp. So the Kp here, referring to the statement 2 to 50 K, the T outlet. So the Kp value falls between this temperature, between 2000 to 2500. Okay, now from here, do interpolation, then you will find your Kp. Okay, calculate first, what is your Kp? Once you get your Kp, you can proceed to find the B using this equation. Okay, once you get your KP, input the value of KP into B equation. Your KP will be the previous 0.19175. Yeah, you should be getting this one. And your B later on, this is your B, 4.9. Okay, try to proceed until you get the composition fraction as your final answer. Okay, once you get the B, C, D, and E, this is not your final answer yet. Plug it into the equation, then find the total mole, then find the final mole fraction of the gases. Okay, this is your final answer. So let's try to do that. For the unknown over here, in previous slide, we put as H2, different unknowns. It depends how you label your equation, okay? So in the previous slide over here, in this slide, T is for H2O. So this one, in this slide, E for H2O. This one is the previous exercise, previous answer. So it depends on what are the letters that you put for your unknowns. Eventually, final answer should be the same. H2O, mole for H2O, which is the E over here, you should be getting this value. So once your B is correct, then the rest should be no problem. You do the balance, then you will get the other unknowns. Okay, now for those who had done the previous question, try this. This is from an exam 2022, last year. Okay, this question, it gives you fuel of equal mixture of butane and methane with air at an equivalence ratio of this. Enter a combustion chamber at STP. Okay, 1 atm, temperature 25 degrees C. It asks you to compute the constant pressure adiabatic flame temperature. TAD with constant pressure. Assume complete combustion. So this one, it asks you to find the TAD, where you need to assume two temperature. Constant pressure. So constant pressure, it involves, it doesn't involve the P, V, and RT equation. Okay, constant pressure for A over here. Equals to 0. So you need to find out the info from the properties table for each of the component. Fuel, we have butane and methane. Okay, as always, first step, you need to generate the combustion equation. Where your fuel is mixture of this. It is, I advise you to find one chemical formula of the mixture where you have a certain number of X and Y over here in order to ease your calculation. So from this one comes from the mixture, molar mixture. So 50-50, 0.5, 0.5. So you will generate one chemical formula for the mixture. Then find the A actual. Equivalence ratio 0.75. It is a lean or rich fuel. Lean, excess air. Okay, so you have excess air, so you have oxygen in your product. Okay, find out the chemical formula of the mixture. This one. Then find the A. A we can get from the equation similar as the previous equation where A actual is X plus Y over 4 divided by the equivalence ratio. This X and Y is from the mixture. Okay, X CO2, Y over 2 H2O. O2 over here is unknown. Okay, so O2 unknown, you can do the balance. The O balance, then you can get the O2. Okay, B is as unknown. B here is not the same as the previous question. Okay, this one just do the balance. Using O balance. Okay, then after that, you will need to find the what? The info of the enthalpy at 298, H at P adiabatic 1, H at P adiabatic 2. Okay, component over here, since this is a mixture, the HF, you will need to find HF for butane and HF for methane. Since this is equal molar, okay, multiply by 0.5. Okay, this is a long calculation, that's why it contribute 12 marks. Yeah, I'll share with you the solution for this. Chemical formula for the combined fuel. Okay, once you calculate the one chemical formula, you will get this chemical formula. Okay, once you combine them, so this chemical formula is the one that you will use for the combustion equation. Okay, because from here you need to generate how many CO produced, how many H2O produced, and then find for the B, mole of oxygen from the balance. Okay, so from here, you can find the A actual using the equivalence ratio. Apart from this equation that I mentioned initially, apart from this equation, you can find from this equation as well. This one is from FU ratio. FU ratio stoic over FU ratio actual. So cancel out the rest. Leave with only the A. Okay, you can also get this equation using the AF actual. Yes. The what? The C here. 0.5, 0.5. It is equimolar. Oh yeah, correct. Here is 2.5. 0.5. Correct. It should be 2.5. Okay, this one make the correction. So this one is 2.5. So this one also should be 2.5. 0.5 multiplied by 4, it is 2 plus 0.5, so 2.5. So 2.5 from here, this one also correct. Make sure you correct. So this one, once you get the A actual, plug in into the final equation. This one correct, this one correct. Try to correct. So this is the one that you will get. Okay, so this one might be slightly different due to the C over here. Okay, focus on the step because this one is typo. Okay, once you get the final combustion equation, extract the infos from the properties table. This one I assume at 800 and 1000. So it's up to you at what temperature that you want to assume. Find all the infos. Then from there, as I mentioned earlier, the heat of formation of fuel, since it is equal molar, so 0.5 multiplied by 0.5 multiplied with the butane and methane. So you will get the heat of formation for the fuels. Okay, so from there, plug in into the equation. constant pressure. This is the equation for constant pressure. If constant volume, different equation, which it involves the PV and RT. Okay, then from there you will get the Q at first assumed temperatures, then repeat the same thing at the second assumed temperature. Okay, you get the figure, then do the interpolation. Okay, the T adiabatic roughly around this, it depends to the temperature that you assume as well. Okay, roughly 2000 plus. Okay, those are the steps to find the T adiabatic. For B, this one, after you obtain the final combustion equation, then do the fraction. Okay, this one slightly different with the answer, the actual answer, since C here should be 2.5. Okay, but roughly this is the method how to solve it. Okay, any questions so far? Okay, in this question, it asks you to find out in wet and dry basis. So wet basis total up all the flue gases, inclusive the H2O. For dry basis, exclude the H2O from the end total. Okay. Okay, for the marks distribution, I have to highlight for the marks distribution, correct info extracted from the table also you will get mark. Okay, so there is marks for the step. Okay, not only the final answer. So that's why I always emphasize on follow the step on how to get the final answer. Okay, show all the steps. For the calculation, plug in all the correct infos in the calculation. Okay, here also have marks if you input the correct values. Okay, any questions so far? Now, this one is also from 2022. You can try this as well. This one, this question, it gives you mixture. Okay, it already mentioned the mixture of the gases where you have the CO, CO2, and NO. And mole fraction of CO is this. And CO2 mole fraction is this. Okay, the temperature, gas stream temperature, 1200. It asks you to determine the absolute enthalpy. Absolute enthalpy of the mixture in both mole basis and mass basis. Okay, this is absolute enthalpy. Okay, refer to the slide. There is one slide that discusses on the absolute enthalpy. Okay, for B over here, it asks you to calculate the adiabatic flame temperature. T adiabatic, assuming combustion is complete and the reactant enters at this. Okay, here for B, how do you know it is constant pressure or constant volume? Which one to use? For B. Constant pressure or constant volume? Since this question doesn't mention anything on the condition, you can assume constant pressure. It will be easier, unless you want to assume constant volume. Okay, it's based on your assumption. Okay, because it doesn't mention on the condition. Any question? You should try this kind of final exam question. and also a question from the textbook, chapter 15. Those involve the fuel and combustion. Next class, I will proceed with chapter 3D, here on the combustion monitoring. Any question before we stop? Okay, if no question, I'll stop here. I will end the session. If you have any question later on, just text me with this. Okay, thank you.